Nick,
Yes, sir. Can you hear me?
yeah, can you hear me okay?
I can.
Excellent. Kind of
We
a
did
rough
it.
morning there. Yeah, kind of a little spooky. Hey, congratulations on the award, man.
Oh, thanks, man. I was caught completely off guard about that. Like just the other day, I was listening to the hacks where you guys were talking about it, and I was like,
Yeah.
I wonder who that's gonna be. And I don't know. I'm overwhelmed. I don't even know what to say. I appreciate it.
Well, we've got a lovely glass cube heading your way.
I think
So,
I would have much preferred the bowling trophy idea, though. I think that would have
right?
been
I
rather
listen.
key.
I know you guys would have for sure. So, man. So, okay, looks like people are hopping in here now. I've got a guy named Nick Garber. Does that name sound familiar to you? Is he going to be involved with this as a moderator?
Nick's not a moderator, but he's a great
Okay.
guy.
Okay. I'm just trying to figure out what's. It looks like Nick is saying, "Sorry, I hit that button by accident. Beginner's mistake." Hold on one second.
Yeah, maybe later on, like after I'm done with the main presentation, we have a little bit of time. If people want to jump on video and like actually talk and things like that, we just open up the floor.
Excellent. Okay, yeah, we can do that. Looks like we're about ready to get started here. Let me close out Nick here. Um, all right. Hey, welcome everyone. Welcome to our special breakout session with the one and only Nick Hughes. Or Nicholas, if you're nasty. Can everyone hear me? Okay, can everyone hear me in the chat? If you guys want to hop into the chat there, let me know if I'm showing up. Okay, I'd appreciate it. Yeah, thank you, Alan. Thank you, CR. Much appreciated. Welcome each and every one of you to SaltConf20, virtually everywhere. This is definitely a new experience for us, in case you can't tell, and I think this is probably a new experience for Nick Hughes as well. So without any further ado, let's get into it here. Want to say a huge thank you to Nick Hughes, EITR Technologies. They're an automation and cloud consulting business specializing in Salt and VMware. They're of course a Salt and VMware partner. EITR Technology. Sorry about that, Nick. Sorry for bobbling that. Nick is the CEO, and he's a good friend. He's a really good guy, and we're grateful to have him here. So without any further ado, oh, by the way, just really quickly, we are going to have a Q&A session at the end of Nick's presentation, but I'm going to be monitoring the chat here. I'm going to turn off my camera and monitor the chat. So if anybody has any questions, feel free to go ahead and raise your hand or type the question in the chat, and we'll get you all squared away. Nick, what do you say? Let's get into this here.
Sounds great. All right. Well, thank you everybody for attending my session here. Thank you, Chunga, for my wonderful introduction. Just a quick show of hands in the chat. How many of you are actually wearing real pants and not pajama pants right now? Notice that my hand isn't up. These virtual formats are great. So as Chunga said, I'm CEO of EITR Technologies. I am an automation consultant. And basically what my company does is I like to think of it as like three circles of a Venn diagram, right? We do cloud, we do automation, and we do cybersecurity. And so when all of those things come together, that's definitely where we fit in, but we do all of that. I am old, nearly 20 years in IT. Been doing a lot of different things over the years. Been a Salt user and contributor for a number of years as well. Really like the platform. I am the cloud working group captain for the Salt open source community. So, if you ever want to get a hold of me, you can jump into the Salt community Slack in the cloud channel and hit me up there and ask me any questions that you need. Additionally, at most of the bottom of these slides, I have my LinkedIn URL, and that's pretty much like the only social platform that I'm on consistently. So feel free to reach out to me there. One of the reasons that I'm giving this talk is because I wrote a bunch of the Azure code for Salt. And by virtue of that, I am now the maintainer of the Azure plugin for the new Idem project. So let's go ahead and jump right in. So first off, we have Salt Cloud. Salt Cloud was created back when cloud service providers really only had compute. You could spin up virtual machines and run workloads inside of the VMs, but that was really it. Salt Cloud carries on that legacy and still really only supports compute. It's a little bit of a different workflow than the rest of Salt. Generally, the configurations are like raw YAML files as opposed to the nested state structure for state and runner modules that you might be used to if you've used Salt before. There are a lot of state modules for cloud things, but they are separate from Salt Cloud proper. So some of the Azure code that I wrote for Salt is execution and state modules that you can use to spin up infrastructure, but they are a separate entity from Salt Cloud itself. And probably the biggest thing about Salt Cloud to be wary of is that it is not idempotent. Unlike the rest of Salt, you can define your compute resources, your instances that you're going to create, and execute that. It'll create them. And then if you want to modify anything, you can't really do that. It checks for a name inside of that cloud service provider that matches the one that you wanted to create. And if it's there, it doesn't do anything. So some things to keep in mind. But the new kid on the block, Idem, it's pretty new comparatively. It was just formally announced at last year's SaltConf, and it's based on the plugin-oriented programming paradigm created by Thomas Hatch. POP allows for plugins to be separated into different code repositories, which can then be modified and released separately from other plugins or applications. Idem has a familiar state syntax using YAML and Jinja, much like Salt in its normal state system, and it's idempotent. So without further ado, let's get ready to rumble. I'd be remiss if I didn't actually say that phrase during this and also have the obligatory rock'em sock'em robots. So let's do a little bit of a Salt refresher, or maybe an intro if you're brand new to Salt. Here's a little bit more info to put things into context. Salt is an automation platform that can perform remote execution. It can run ad hoc commands on systems, configuration management, keeping systems in spec, and probably the most powerful feature, event-driven automation, reacting to events in the field and taking action on them. The default configuration is a client-server architecture, but you can also run it with SSH transport from the master, or you can run it masterless without any master at all. And all of this can happen at massive scale. SaltStack recently performed a test where they ran commands on 1 million minions all at the same time. And it was actually pretty snappy. So a little bit about the architecture and installation of Salt Cloud. Salt Cloud, as I mentioned, is a separate installation package from the Salt Master or Minion. It is often installed alongside the Salt Master, although that's not required to install it that way. It is the easiest way to take advantage of all of the features of Salt Cloud, specifically like minion bootstrapping, where you precede keys in the master, and things just happen magically once you spin up the instances. It can talk right to the master without having to accept the keys. And then also registering the cloud events on the Salt event bus. Anytime you create any instances, that creation can be registered on the event bus, and then you can react to it. It can be installed via packages, system packages, or pip. And like the rest of Salt, it is very pluggable. You can extend Salt Cloud with new clouds or add functionality to existing clouds. And then that functionality can either be contributed back to Salt and integrated into the huge monolithic code base, or you can maintain it separately and then integrate it into your environment. One thing about committing back is that since Salt is on a quarterly release schedule, you might have to wait a few months for the cloud code to make its way into a stable release, which admittedly is a downside because that is forever in cloud time. Okay, so a little bit about the configuration of Salt Cloud. It can get a little complex. All these config files in the diagram here are basically merged together in order to build instances. So if all of those configurations end up being merged, where do certain configs go? So at the top here, you have your main cloud config. Those would be your Salt level configs, any shared provider configs that might be shared across an Azure, AWS, VMware, and so forth. Generally, that equates to like log levels, timeouts, things that are going to be applying across everything. In the next tier down, we have our provider configurations. These are going to be your cloud level configs. Maybe some generic instance level shared configs. So you might have providers for AWS and Azure and VMware, as I said. And then providers can also extend other providers. So you could potentially have two different providers named separately that both reference different configurations of an Azure provider, for instance.
Hey, Nick, can I jump in here really quick?
Sure.
Alan Kugler is asking, he asked a question, no maps config?
So I stole this diagram from the SaltStack website, which doesn't have a picture of maps, but you can see the last bullet point, and the last thing that I was about to say is that there are maps. So maps are basically lists of instances that build on profiles. So just to talk a little bit about profiles, since I jumped over, we have profile configurations that contain all of the configurations to create an instance apart from its name. It's basically a template, right? And profiles can extend other profiles so that you can build on all of them. And then maps tie all of that together as a list of instances that you're going to create that use a certain profile type. And you can also add more configuration information to a specific instance. And I'll show some examples of what these configurations actually look like. So with these configuration examples, the smallest one in the top middle there is actually the top level cloud config. As you can see, I don't have a whole lot of stuff in there right now. It really equates to being the log level and enabling cloud grains, which is like instance metadata for your cloud deployed instances. On the left, however, we have a provider config. So this particular provider is an example of what an Azure config might look like. I separated it into different sections that have comments. Not going to go over all of them, but towards the bottom, you can see that we're using an Azure service principal in order to connect to a specific subscription in order to take action inside of that cloud. Additionally, we have some other configuration information. You can see in the second section down where it says install Minion software using private IP, we're specifying that the Bootstrap interface for deploying, you can see deploy equals true, the Salt Minion software onto new instances will use the private interface. So we expect our Salt master to be on a private network inside of our cloud that the instance can access. Moving forward into cloud profiles, that's going to be the middle screenshot on the right. we have a couple of provider configs. So here we're showing that we have an Ubuntu 18 profile and a CentOS 7 profile. Each one of those is pointing at our Azure provider on the left. We're also specifying the image that's going to be used for spinning up that particular instance type. Notice the pipe delimited string there for image. The way that Azure identifies its images is via dictionary. So I guess this was decided on quite a while back. But basically, you specify each one of those particular dictionary keys as a pipe delimited string. So Salt Cloud will take that string, break it apart into its 4 components, which is like the provider of that particular image, the type of image like Ubuntu or CentOS, and then the version, overall version, and then like the actual, I guess it ends up being a date string for a lot of image providers of like when that actual 1804 or CentOS 7.5 or CentOS 7.7 and so forth image was actually created. So in those profiles, we have some minimum configs in order to spin up instances inside of Azure. It's really amounting to like the size of it, the resource group that's going to live inside of, and then the virtual network that's going to attach to along with its subnet. And then finally, we have our map file. And as you can see at the root level of that YAML, we have the profile names and then a list of instances underneath that are going to use that profile template and build an instance inside of our provider. At the very bottom of the map, you can see that DB1 is not just a string, it is actually a dictionary. And this is how you can override particular configuration items for one instance. So you can see that DB1 is using the CentOS 7 profile. In CentOS 7, we have turned on the allocation of a public IP by default. So it will have a public IP. And then for the DB, the database node here in our example, we're telling it, hey, we don't want a public IP. So that's one way that you can override those.
Jump in with one more question here, Nick.
Sure.
Again, coming from Alan Kubler. Thank you, Alan, for your question. It says, how do you prefer to query those valid key values for each section, which is on the image?
Are you talking about like how do I get the values within that pipe delimited string? Like how do I know that that's what gets me a CentOS 7 image?
I'm assuming he's saying yes. Yeah.
Yeah. So Salt Cloud does have a way that you can list images. You can imagine how many images are actually out there in Azure right now. So despite the fact that it does sort of fan out and perform the query, it does take a while to return that information, and there's a lot to dig through. So probably what you're going to end up doing if you're using the standard commercial images is using the UI in order to look that up, and then you dump it in here. But we can talk a little bit more about that probably at the end. Cool. So this is our basic configuration just to get a few instances created. What about the infrastructure, right? We have a resource group and a network or subnet that we've referenced. Does Salt Cloud create those? No, it does not. So it has no mechanism by which it can create infrastructure. So what people end up doing is using orchestration in order to take steps to create infrastructure first and then spin up their instances inside of it. So you can see our orchestration state that's on the left. The first thing that it does is call the infrastructure state on the right. And then it runs the map from the previous slide. So, you can see that the runner module for the cloud map run references the full path to our map file from v4. It executes that in parallel, and it requires that the infrastructure complete successfully before it moves on. This is all like really quick and dirty high-level examples, by the way. So on the right, we have our Azure infrastructure state. And really all that's doing is grabbing our credentials out of Pillar because we aren't passing anything in via the orchestration. We're getting that information independently. And then we're passing that to each one of the Azure states and creating a resource group, a virtual network, and a subnet. So all of that should occur, and then the instances will be created afterwards. And just to drive home kind of that workflow, you can see that we have 3 different swim lanes here. We have the Salt master, which initiates this whole process through a runner process for orchestration. It jumps down to the Salt minion below, where the resource group and virtual network subnet are actually created. That return is sent back to the master process, and then it moves on with its life and performs a map run using the Salt Cloud software, where it actually creates the instances, any associated network interfaces, and then any public IPs as well. That's basically the extent of what Salt Cloud can do inside of Azure right now. It can create those instances for sure, the associated network interfaces with some limited tweaking functionality, and then the public IPs that it can attach to those instances, again, with mostly limited functionality. Okay, so now we're going to shift over to Idem. Sort of as a little bit of background, POP stands for Plugin-Oriented Programming. It is a paradigm that is written in Python, again, created by Thomas Hatch. And all POP apps that are installed together can access each other at a central location called the hub. Basically, they form like Voltron for the purposes of code reuse and coming together to form new applications by combining capabilities. It's a really cool concept. And if you want to learn more about this, definitely check out Tom's talk on POP right after this session. But basically, what it allows you to do through the hub is access functions and data inside of that framework, much like one big self in programming. So to move on a little bit to Idem specifically and the architecture and installation of that, right now Idem is a standalone command line app. It is pip installed. Again, it's based on POP, so it's incredibly pluggable. Each atomic unit of work gets its own repo and release cycle. So you can have plugins or other POP applications that exist in any repository all over, right? We have Azure functionality as a separate plugin repository inside of GitHub. Idem is a POP application that exists inside of GitLab. Elsewhere, pick whatever code repository you want. You can create a POP plugin and integrate it pretty easily just through pip installation. It's pretty neat. The one thing that I will say about Idem is that Salt support isn't totally there yet. Most recently, we can now execute Idem states from within Salt, starting with version 3002, which just came out, thanks to Tyler Johnson. Support for minion bootstrapping is planned. So having that tight integration with the master where we can precede keys, we would love to get that functionality built into Idem proper. And we've been talking about event bus integrations as well and kind of how that would work. So, you know, a lot of interesting Salt support coming. So let's get into the configuration of Idem a little bit. Basically, credential handling is handled by a separate POP application called Account. That's ACCT. It allows you to specify your cloud credentials inside of a YAML file, and then it encrypts that file with a symmetric encryption algorithm called ForNet. And then you can present the path to your encrypted file and the key as environment variables before you run Idem. You know, that's sensitive information, obviously. So you want to protect that information. And there are some other things that we'll go into next, ways that we can take advantage of that. About the structure of the file itself, the root node of the YAML file is the name of the POP hub location that is going to make use of it. So the Azure plugin for Idem is called Azure RM for Azure Resource Manager. It's the newer version of Azure's API. And then underneath of that, we have a profile name by default. It wants to look for a profile name called default. And then we have our service principal credentials underneath of that. We could have another profile for Azure RM as well, name it whatever we'd like, and then have a different set of credentials that we can specify, hey, for this particular state, I want to use this account profile in order to create in this separate subscription or with a different level of privileges, whatever you'd like. So a little bit more about credentials that I teased. What if we don't want credentials on our host? Idem Azure RM can take advantage of managed service identities. You don't need to put any credentials whatsoever in account. It does require that you specify a subscription ID, which isn't terribly sensitive. So your YAML file might look much smaller. You basically have Azure RM and default, and then your subscription ID that's going to be your default subscription ID. But that's basically it. Everything is handled under the hood by Azure itself, which is nice. Another thing that we recently introduced is the concept of a key vault backend for account. This particular functionality you could actually grab out of the code base and implement with literally any Idem functionality whatsoever, which is nice. It's sort of an atomic unit of work. But what it allows you to do is retrieve credentials for other Azure tenants or other clouds without having to build trust relationships for managed service identities or save credentials on the file system. So this is a great workflow for managed service providers or people who take care of like client accounts. You could have an Azure instance inside of your infrastructure with managed service identity access to a particular key vault, and then point account to that key vault, and then retrieve whatever credentials out of there you need in order to do your job in other people's cloud accounts or other external providers such as AWS and so forth. All right, let's get down to brass tacks here. So we're finally at the point where we get to see what an Idem cloud state looks like, and it's probably pretty underwhelming. It probably looks a lot like what your Salt states look like. So we can implement the same logic that we showed in Salt Cloud within a single state file. And it looks pretty much the same, as I said, but notice the multiple dots in the state module name. We have azurerm.resource.group.present. Currently inside of Salt states, you basically have the ability to namespace once, right? You have a module file name. So it might be Azure Azure ARM underscore compute, I think is the name inside of Salt proper, and then a dot, and then the function that you're going to use inside of that. Inside of Idem, we can namespace inside of folders and levels deep. And that really allows us to segment our code into much smaller files, which makes troubleshooting a lot easier and management of that code base. So this is a continuation of the previous slide. As I said, this is all taking place inside of one single file. And we could define all of these as static YAML blocks for each specific instance, but we are using Jinja to loop over the blocks and create multiple instances. So in the first section, you can see that we're creating two Ubuntu instances, and we're naming them VM1 and VM2. And then just below that, we are iterating over top of a dictionary of instances where we can pass in other parameters and pull information out in order to like override the allocate public IP flag. And also notice towards the bottom there in the user data section, I have an example of how you might bootstrap a Salt minion that's created by Idem right now. You will have to accept those minion keys on the master through some other process, because as I said, Idem doesn't have ties into the master right now. But you can certainly put a reactor in place in order to accept those keys for you. So let's talk about one more thing regarding how these state files can be structured. So you can use execution modules in all parts of Idem. That's one thing that you don't really get inside of Salt Cloud proper, is access to the execution modules inside of Salt. You can use Jinja, but a lot of times you don't have access to exactly the same namespaces that you might expect inside of the code. So I just wanted to highlight that because it's sort of one thing and one different workflow, we can use execution modules here. And that is because the pop hub is accessible in Jinja. So you can see in all three of those Jinja lines at the top there, we are accessing the hub and different namespaces underneath of it in order to take actions. Just as a note, this file, we are listing all resources groups inside of our subscription and then enforcing their absence. Don't run this in your account unless you want to completely wipe everything out. If you delete a resource group inside of Azure, it deletes everything inside of it. Think of it as deleting a directory. So let's shift back to Salt Cloud. Right now, Salt Cloud has a fair amount of cloud provider support. The clouds in bold are probably some of the most popular ones. That's mostly due to me hanging out inside of the Salt community and sort of seeing where people ask the most questions. So if you don't see yours bolded, I'm sorry, I didn't address your particular cloud that you love the most. But I just picked a few off the top of my head. Let's see here. Some of these, especially, I was trying to think of one that was deprecated entirely. The name escapes me. But these might be in various states of disrepair. So if you're using a less well-known cloud, definitely be on the lookout for anything that might be weird or downright broken, and definitely let us know. On the item side, we are still in the early process of getting more clouds into the mix. The Azure provider is fairly mature. It's been around for a year as Idem has evolved. Just before SaltConf last year, Tom reached out to me and said, hey, can you port some of the Azure stuff that you did over into this new product that we have? really love to see like a POC. So it is the oldest. But we do have some new players as well. Documentation might be kind of light on some of these, so feel free to reach out on the SaltStack community Slack for more information. But we do have an AWS provider that's currently in process, and there's a lot of great functionality that's being built there. And then also we had Vagrant and VirtualBox and Vultr, which were some of the smaller things to port over. And also, I guess somebody started with the Vs. So those are out there as well. So feel free to check those out if you have some time and some interest. We also have other clouds that we're thinking about and are planned right now. We are looking for contributors that can help us do any of these things. So if you know any of these cloud providers, or you'd like to learn them, because it's a great way to really learn the APIs very well, definitely reach out and we'll help get you started. So we are back to Salt Cloud again, and we are looking specifically at Azure. So as I've stated multiple times, Salt Cloud can really only spin up instances. It can do some light work with network interfaces and public IPs. And that's really all Salt Cloud can do. So if you're doing a direct comparison between Idem and Salt Cloud, you stop there. But to give them the benefit of the doubt, we could talk a little bit about the states that exist inside of Salt as well. There's a lot of decent infrastructure support that we built in there that allows you to sort of build the framework that you're going to lay your instances inside of. But Idem has all of that and more. Special thanks to my buddy Alex Rothman, who did a lot of this work because I've been super swamped over the course of this past year. But some of the cool ones that we have now are Azure Bastion, container instances, container registries, Azure Database for Postgres, Azure Functions, Key Vault support, Redis, storage accounts, VNet gateways, and peering. A lot of cool functionality that we have now. All of the bolded ones are new to Idem that do not exist right now inside of Salt. So let's talk a little bit about roadmap. So on the Salt Cloud side, what's in store for Salt Cloud? Probably not much. This is a pretty empty slide. It would be pretty difficult to completely re-architect Salt Cloud within the existing code base. And there's probably not much reason to do so since Idem is in town. We're just gonna keep up Salt Cloud as best we can. If you have any bugs, definitely submit them. Definitely let us know in the community, and we want to address those. But we're directing most of our concentration on new features into Idem. So Idem, on the other hand, we have more Azure services that we'd like to implement. I was hoping to have AKS done by this conference, but it's only so many hours in the day. We're also, as I said, still working on the AWS provider, and there's more and more services being added to that all the time. More clouds. We're interested in getting more clouds out there for people to use. So if you have one that you love, we're definitely interested in hearing about that. Also been a lot of talk about doing more inside of Kubernetes. Also thinking about how we might do drift detection, kind of like Terraform. So right now inside of Idem, you basically have your local intended config, right? Your state files. And then you have the what's in the cloud itself. And so when Idem runs, it checks your states and makes sure that those particular things are configured the way that you want them. But it doesn't necessarily care about things that aren't listed locally that might have been changed in the cloud. So if we can implement some sort of drift detection, that implies that we're keeping track of a third state, right? You know, what was the state of our cloud provider the last time we ran Idem? So you would develop a state. It might only have a few things in it. You execute that state, and then the cloud provider creates that object, and it might have tons of defaulted parameters. And then we grab that whole object and we store it somewhere. So the next time you run it, we can say, oh, you know, it looks like somebody changed a tag or something like that. Another cool thing that's been tossed around just recently, and I've started taking a look at what it might take to actually do, is diagram creation from your Idem state files themselves. So if you can specify some sort of like layout or directionality between objects inside of your state file, it would be somewhat trivial to be able to run a special command that creates a diagram file of what your intended architecture might look like. So to me, this seems like a really cool feature that might save some people some legwork on creating documentation and sort of diagrams of the things that they're implementing. So I'm really excited about this potential feature and working more on that. And then finally, we have Idem in general is going to be exploding more, right? So I've talked mostly about Idem in its cloud capabilities because that was the first thing that we set out to accomplish on a pretty broad scale. But Idem really is, if you took Salt's state system and airlifted it out of Salt and then used it to do stateful enforcement of things in general. So, you know, I'll be on the lookout for you know, package management, file management, you know, service start, stop, things like that. All of your normal configuration management workflows, I think, will eventually start to show up inside of Idem as well. So, as a comparison, no, there is too much. Let me sum up. Salt Cloud has better integration with Salt. It has more clouds supported right now, and it's been around long enough to be pretty robust. Idem Cloud has faster releases. We can iterate as fast as we want. You know, if we find a bug, we can cut a release that day. It has more Azure support right now than Salt does. So if you're an Azure person, especially, please take a look at Idem and give us your thoughts. And then finally, it can take advantage of literally any POP plugin or application as they are developed. So that's one of the most exciting things about the POP ecosystem is that as different applications and plugins show up inside of POP, we can evaluate those for inclusion into different workflows that we already have in other parts of the ecosystem. Or, you know, if you're referencing, you know, something via Jinja and accessing things in the hub, that application functionality will just be there by pip installing it. You don't have to do anything, which is really, really cool. So we're at the end of our time. I have some references here that I put inside of the slide. I'm not sure how these slides are going to be shared. So if you want to take a screenshot of this, I heard that the sessions will all be recorded and posted somewhere, potentially next week. But if you want to get started now, the first link is the Idem Azure RM plugin repository. It's hosted by my company, and it has pretty good README. The docs link is also right below it. That goes into a little bit more detail on some topics and doing specific things. Additionally, my company, we tend to blog about this some. I don't have anything that's super recent. I need to get on that. But you know, we do have an RSS feed that you can subscribe to and maybe get updates as we start to see cool new features show up inside of Idem. In the second section there, we have the Idem Cloud repository in SaltStack's GitLab. Inside of that project, there is a Kanban board with the different clouds that I spoke about today. So if you want to know this current status of any of those clouds as they sort of progress, definitely check that out. Additionally, the POP group underneath of SaltStack's organization there has a ton of POP-related projects right now. Additionally, there is a repository called pop-awesome. And really, it's a README file with a bunch of links to other POP projects that might not exist inside of that group. So if you want to see what other POP things are occurring out there, definitely check that out. And last but not least, Tom loved POP so much that he wrote a book about it. It's up on Read the Docs. After you check out his session after this, definitely read that book. It's a great breakdown of kind of why he implemented the paradigm, kind of how it works, and it's not a terribly long read, so go for it. So finally, I just wanted to thank everybody for sitting around and listening to me for a while. I certainly appreciate it, and I just want to give a quick shout out also. The gentleman here that you see before you and featured in many of my previous slides, it's a good friend of mine, Luther. He's a professional fighter and an entrepreneur multiple times over. Definitely check him out too. So with that, let's go ahead and see if there are any questions.
So here's how I'd like to do this, Nick, if you're okay, and to all of you who are attending this awesome breakout session. By the way, well done, Nick Hughes, the award winner, Nick Hughes. You killed it, and I happen to think that Idem Cloud, Pop, Heist, Umbra, all of the new products that Tom's been working on, these are some of the sexiest things that I've been involved with since I started at SaltStack. So well done. Anyway, if you have a question, why don't you go ahead and write it in the chat here, and I'll go ahead and read them. We have a little bit of time. Alan has lots of questions, which is fantastic. He said, I think I missed it. Are we using Idem as a salt run runner, or is it more of an execution module to have a minion run?
So the code that was just added to 3002 was a minion side process, so you can execute the item states through Salt's state system. So it is not a runner module.
Okay, got it. Anybody else have any questions here? Just go ahead and jot it down in the chat, or if you would prefer, I think you can share your audio and video, and you can hop in here really quickly. I think we can hold it.
Or if you don't have any questions, we can just talk about whatever. You guys got me for a few minutes.
Why don't you tell us more about your company real quick for people who may not know?
So just to give people a sneak peek into the previous processes of this conference, a couple of days ago, Chunga and I jumped onto a session, and he was like, I loved your presentation, but you need to talk about your company more. And I'm awful about like self-promoting, but I will say that I just want to help people get stuff done. I'm pretty passionate about automation in particular. And so if you ever want to talk about any things that you might be trying to implement, and you don't want to talk to a salesman, I'm your guy. Because I just want to try and help implement solutions. So I'm probably going to get slapped by my business partners for saying that, but that's probably my primary motivation is really just like making the world a better place, which I know kind of sounds sappy.
It's only sappy if you think it is, Nick. So Alan has one more. He says, do you feel Idem will enable a more provider agnostic infrastructure? It's a great question, actually.
I think it's so great that I'm not quite sure exactly what he's trying to get at. So are you talking about like abstracting it to the point where you could just say, hey, I have defined this instance, and you could maybe through one parameter swap out what provider it's going to be created inside of? Because if that's what you're getting at, it's something that we've talked about. And I think as we get more providers in the mix, you might start to see that abstraction, where you could potentially define an instance in a generic way, and then just swap out where it might live. It kind of makes me think of the way that libcloud has been tried to be implemented, right? Where you can just sort of say, oh, I have an instance of this like general quality and size. Let me go ahead and change Azure to AWS and then hit go, and it just happens.
Okay, let's see. I'm going to turn on Alan. Alan, I've read so many questions, man. I'm just going to turn you on for a second, and then we'll call it good. There he is. Alan, thanks for hopping in, man.
Yeah, sorry for so many questions in the chat there.
No, never be sorry. That's what this is for.
Yeah, so I was asking about the agnostic infrastructure of being able to flow from like GCC to AWS to IBM. So as those providers give like new infrastructure products that like someone might want for their business, or that one becomes cheaper than the other over time. And so do you feel that like the item is good enough that instead of it being like a 6-month migration, which has been like historically something that happens in the past, do you think like this will be able to make migration to a different provider be like weeks or days?
So I want to say yes, but there's definitely some hurdles that are going to have to be overcome, right? So the providers are different enough in how they implement a given object that if you try to abstract that in some way to something more generic, you're inevitably going to lose some functionality. So as long as somebody is sort of implementing their infrastructure in a very generic way, I think that you could definitely do that fairly easily. But the thing that I worry about, right, is all the things that are going to be specific to a particular provider and how they implement a virtual machine or load balancer or something like that. I think that it could potentially be different enough that people won't use that abstracted vanilla type of quality to it.
Okay. Yeah.
And all right. Hey, thanks. I think we're going to have to cut it off, unfortunately, because I think we're going to be starting another session in this room very, very soon. But please feel free to hit me up here within Hopin, and I can get the questions to Nick, or you can reach out to Nick himself, and he can take care of you further. So thanks all of you for hopping in. Applause. Ken is saying applause. Absolutely. Well done. Give it up for Nick Hughes.
Thank you.
Outstanding job, sir. Always a pleasure to see you, and you did it. You're done.
Thank you very much. I'll talk to you guys soon.
All right, Nick. Bye-bye.